Hello, I'm David Vandergriff here at Purdue South Bend, and this is our Tesla turbine. Ben is behind the camera right now. So what we got here is a pretty basic Tesla turbine. We were able to 3D print it out all right. No problems at all with that. This is our first print. Everything worked good. We have several bolts here that we purchased to secure it, as well as little M8 nuts there to hold it in place. The next thing we did, Ben designed this little fin for us, and we put some aluminum foil on it just in case, just to help it be able to read through it better. We have that secured with several bolts. On the back side here we have several bolts as well. We have those bearings on the inside of there as well. So the way this works is when the air comes through here, through the hose here, it'll blow on these discs. Here, a couple. We have 17 of these inside of the turbine, and when the air blows on it, it creates friction and it starts to spin, which in turn will create rotational energy here, which will allow this to spin. Starting here, this is our light sensor. This is the beginning of our feedback loop here, so it picks up the rotations and transfers that to this Arduino, which has some coding to be able to turn that rotational speed, or the information being sent from the sensor into RPMs. And with that, we're getting that signal out of here into the Arduino, and it's being powered by this power supply here. What we have here, this is our valve controller, and that we have that currently at 0 since we have our PID set to 0 as a set point. It outputs 70 milliamps. So yeah, there's that. And then if I spin this, then this will go up too, as you can see. Well, no, it wouldn't go up because it's not going that fast, but beside the point.
It's the RPM that goes up.
Yep. So, we have that. And we have our control plus and control minus going into channels 11 and the 0 volt signal there. And if we want to come over here, I'll show you our PID, our PID coding. Finishing up over here, the controller will send a signal to this valve, and this will allow air to run through. Currently we're running at about 100 psi. We looked up the cut sheet for it, and it had lines from 25 psi, 60 psi, and 100 psi, and 100 psi worked the best. And that really allows us to stay in the middle of our output. So when it gets the signal, it'll release air into here and come out. So right now we're at our set point of about 10. We're getting some very nice oscillations, especially around the midpoint there. And I'm going to go ahead and apply some brake to it pretty substantially. Output's going to jump up, and then I'll let go, and that should jump up. A little bit of overshoot, drops back down. Seems very good overall.
The system starts to even out.
Thank you.
Oh. There you go. Closer.
There we go. Right there. That's about there. That's about the average in this group.
Yep.